Okay, we'll try to keep this short. Remember I was talking about how I always talk about how mathematicians are lazy, right? What we can do to shorten, we will. It gets to the point where we invent a new mathematical little symbol and language to communicate our thoughts concisely, we will. That's essentially the heart behind all the advanced math that we have, right? You might not have heard of matrices, but it makes calculations very, very efficient. Using that same language called matrices that they invented, they took it and turned it into crazy things like cross product, dot product, Riemann sums, all these different things that sound lofty, but it's based on a new system that they created because it was efficient. You might have heard of the word calculus, okay? There was something that people like Isaac Newton wanted to do with math, but couldn't because the math wasn't invented. So you know what they did? They invented it. And it made life so much easier. And the rest of the world just took it by storm because it was so incredibly efficient. It's the same thing. So here's a very simple new language, something called scientific notation. People heard of it? Yes or no? All right, so half the class. I'm going to ask everyone to try to buy into this, drop their phones. Here we go. If I have a huge number, and either there are way too many zeros that we don't want to write, or none of these are quote unquote significant, like significant digits, significant figures. You might recognize these words. We try to write it in a shortened way by turning it into an exponent with a base of 10. Let me try to explain. If you want to write what is this? Million, billion, trillion, quadrillion, quintillion, sextillion, septillion, 8 octillion. Sorry, 6 octillion. Instead of writing that many zeros, like 8 times 4, 24 zeros, we would rather simplify it into an exponent. How do I simplify it as an exponent? Well, this is just 10 times, 10 times, 10 times, 10 times, 10 times, 10 times. That's a really long one. You get the point. We're going to shorten it up. Okay. In the same way, if I can make the number bigger by multiplying the tens, we could also make the number smaller by dividing by tens. So you will see huge numbers and small numbers can both be expressed by what we call scientific notation. Here we go. How powers of 10 leads to scientific notation. Notice, if I have something to the power, 10 to the power of 5, that is the same as, 10 times 10 times 10 times 10. Oh, 10 times 10. You can't even see that, right? And if I take this and I multiply this by 4, this is for example, you don't have to write this. If I multiply this by a 5, then that equals 500,000. Instead of multiplying this by a 5, why can't I just multiply this by a 5? It's so much faster to write, so much easier to write. And I don't have to count how many zeros there are. I can just look at the exponent. So there's a reason behind all of this. In the same way, if I want to write 0.1 decimal place, 2 decimal place, 3 decimal place, 4 decimal place, 5 decimal places, I can instead write that as 10 to the power of -5. So all we do is look at that number and say, okay, that's how many decimal places we have. That's it. So just to get used to it, 10 to the power of 4, 10 to the power of 6, -2, -4, please expand this and evaluate it without a calculator. I'll give you 30 seconds. Go.